Okay, so again, here's our toolkit scoring function. And as it would be graphed using the standard values, you'd have a point here, you have a point here, and a point here. Actually, point here, you know, okay, so we've got the 1, 2, 3, 4, 5, 6, 7 values that we get from the standard table. The toolkit scoring function, all those points are on this graph, and the graph fits inside of our 4x4 rectangle. I want to go ahead and in a little more detail do this first transformation, horizontal shift 1, vertical shift of 3. So to be a little more careful, I'm going to have a straighter line there, but okay. Here's my X, here's my Y. I'm going to go out here to a scale of 8. And I'm going to subdivide my interval from 0 to 8. Give myself 4 here, 2 here, 6 here, and 1, 3, 5, and 7. And over here, of course, I want to have 2 units on this side. Okay. Now I should have made my y-axis just a little higher. I'm going to go ahead and put that little modification. And if 8 units is here, I'm going to set this up so we have pretty much equal scales on the X and Y. So we've got 8 up here. So if I subdivide that, I get 4 about here. Then I'll have 2, 1, 3, 6, 7, 5. Okay, so now I've got a pretty good scale for my y-axis. I'm going to take my 4x4 rectangle. And I'm going to do the first transformation where I move this rectangle over 1 unit and up 3. Okay, if I move it over 1 unit and up 3, well, that's going to take this lower, sorry, yeah. Sorry, that's going to take this lower right-hand corner over 1 unit and up 3, as before, and put it here. And this one's going to go over 1 and up 3. That's going to put it here. And then this is going to go over 1 and up 3, which will put it here. And this over 1 and up 3 here. Right there is our new rectangle. If I draw the axis of symmetry, well, the axis of symmetry was the y-axis. It's moved over 1 unit. So here's our axis of symmetry. For the parabola. You don't always have an axis of symmetry, but anytime you do have an axis of symmetry, you probably want to draw within your rectangle. Okay, so there's our axis of symmetry. If I draw my parabola, we'll go here. And the original parabola was here. We say that we've got a pretty good copy of this parabola, but it's over 1 and up 3. Well, I want to just talk about just a little bit of symbolic expression, a simple symbolic expression. Okay, now this graph is the graph of y equals x squared. I'm going to claim that this graph is the graph of y equals x minus 1 squared plus 3. Now, I'll explain that in more detail why it should be this way, but I just want to assert that this is what we got, okay? That if this is the y equals x squared graph, if we move it over 1 unit and up 3 units, we get x minus 1 squared plus the quantity x minus 1 all squared plus 3. Let's test this. Okay, can you give me a point on this graph? Okay. Point on the orange curve. List a couple of points on the orange curve. Should be fairly straightforward. For example, we have this upper left-hand corner. This upper left-hand corner came from moving this point, which is -2, 4 over 1 unit and up 3 units. Okay, so what are the coordinates of this point? Well, we start at x equals 2 and move over 1 unit. We have x equals 3. So I know the coordinates of this point are 3 and something else. Okay, now I'm at y coordinate 4 here. And if I go up 3 units, that's going to put me at y coordinate 7. Okay. Well, hopefully you've listed a couple of other points. You can actually take the coordinates of the 7 points on the basic toolkit squaring function and add 1 to each of their x coordinates, add 3 to each of their y coordinates, and you're going to get 7 points on this graph. I'll list them in a while, but you could do that. But certainly you could tell me what the coordinate of this point is. You could tell me what the coordinates of this point is. Right? And then maybe at least one other point. So you should take time to do that. So you really understand what you're doing. List at least 2, 3 more points that would lie on the graph of this curve without using this formula. Okay, well, hopefully you've done that. Okay, now let's test this. Does the point 3, 7 lie on this graph? So let's move this off. So we ask the question. It was line the graph of the function. How can you answer that question? Think about it for a minute if it's not clear to you. Okay. Hopefully take a little time to think about it. Pause the video, think. The more you do that, the more you're going to learn. And it takes a little extra time, but it saves you time in the long run. So make sure you're doing this. Okay, so what we want to say is if x equals 3 and y equals 7, does this satisfy those coordinates satisfy this equation? Bad looking 3, but hopefully you can see that. You should get 7 equals 3 minus 1 squared plus 3. Work that out. And be sure you do work that out. Take whatever time it takes. Okay, so you should work that out. You get 7 equals, well, 3 minus 1 is 2. Now, if you didn't get it before, can you get it now? I think everybody's gonna get this, but it's not there. It's the thought it deserves. Oh, there it is. The answer is yes. Okay. Well, now you probably figured out the coordinates at this point. I mean, you can see it on the graph, it's 3 here and 7 here. Okay, so if X is, uh-oh. You know, I don't know where I got, I know where I got 3, I was moving up 3 units. And 3 stuck in my head. Obviously, this coordinate is not 3. 3 is all the way over here. This should be 1. I think actually I was thinking about that point. This point is 3, 7. So what I said, if it confused you that I had 3, 7 here, yeah, okay. You'll see me make mistakes. Go ahead, at least in your head, assert yourself. Man, no, that coordinate was not, X coordinate was not 3. So I apologize for the confusion, but hopefully everything we've done previously with these graphs made it obvious to you that that couldn't be 3. Again, I apologize for that. Okay. This point should be 3, 7. Here's 3, here's 7. And we did verify that 3, 7 lies on the graph. Okay, well, go ahead and do it for 1 second. And then do it for this point. What's the coordinates to this point? 1, 3. So I'm not going to do this, okay? Except since I made a mistake, I'll do 1, 3. And all that 1, 7, it's negative 1, 7. 1, 7 would not work. If X is negative 1, that'll be 7. Sort of out of board space. We're going to do the 1, 3. What I'm going to do this time is I'm just going to let X equal 1 and plug it in here and see if we don't get Y equals 3. Let's say if X equals 1, Y equals 1 minus 1 squared plus 3. Of course, 1 minus 1 is 0, 0 squared is 0. We get 3, so that checks. Okay. I'm going to ask you to do one more thing. We know that the points here, well, we know what the seven points of the toolkit, basic toolkit squaring function are. Negative 2, 2, negative 1, 1, negative 1/2, negative 1/4, 0, 0, 1/2, 1/4, 1, 1, and 2, 4. Okay. Now, if we take each of those points and move it 2 units to the right and 3 units up, what will the coordinates be? In other words, can you list the coordinates of the transformed basic points? Okay. 7 points there. What would their coordinates be? And this thing is moved over 1 unit and up 3 units. Hopefully you listed those. And And so I'm gonna say. Basic tools that square function, remember, is to set -2, 4, -1, 1, -1/2, 1, 4, 0, 0, 1/2, 1, 4, 1, 1, and 4. Right? Shifted 1 unit right. 3 units up. In other words, 1 unit horizontally, 1 unit right. 3 units up is 3 units vertically. What do we get? Well, we get -2 plus 1, 4 plus 3. -1 plus 1, 1 plus 3. -1/2 plus 1, 4, 1, 4. Center. Gives us -1/7, which we already did look at. Gives us a new one here, it gives us 0, 4. -1/2 plus 1 is 1/2. And 3 1/4. Okay, well, 3 1/4 is 13 fourths. And then 0, 0, 0 plus 1 is 1, 0 plus 3 is 3. And then 1, 1, it gives us 2, 4. And 3, 7. I'm missing the point. Okay, I didn't do 1/2. Well, 1/2. This should have been -1/2. Well, this should be 1/2. This should be 3/2. Sorry. Maybe we should have the point 3/2, 13 fourths. We're not going to worry too much about that, but let's look at these points: 0, 4, 1, 3, and 2, 4. We've already looked at 2, 7. Well, we can plug any of these coordinates into y equals x minus 1 squared plus 3. And get the y coordinate. Well, you should actually do that. Plug these coordinates, plug this x coordinate in, see if you get y equals 4. Plug 1 in, see if you get y equals 3. Plug in 2, see if you get y equals 4. Plug in 1/2, see if you get 13 fourths. Plug in 3/2, see if you get 13 fourths. If you want to understand this, it would be a very good thing to do. I'll just do one of them, and I'll do one with fractions. X equals 1/2. Now, this is an arrow, it's not an equal sign, it's got an arrowhead on it. It means implies. If X equals 1/2, then Y equals 1/2 minus 1 squared plus 3, which is negative 1/2 squared plus 3. Negative 1/2 squared is negative 1/2. Well, you know, we would take the toolkit function, that's 1/4. And if my conversion to the improper fraction is correct, that's 13/4 or 3 1/4. Does that make sense in terms of the graph? Well, if X equals 1/2, that would be here. So if we come to X equals 1/2, one up to here, and then come across to the Y-axis, it's very plausible that's 3 1/4. You can take each of these points, each of these X values, and see if X equals 2, well, this graph went right through the corner of this rectangle, which is at the point X equals 2, Y equals 4. Understand this in detail. And I don't know why the stupid camera did what it did. I hadn't looked back at it in a while. I think everything should be clear. This is very irritating property of this camera. We're still recording. Okay, well, it takes. I'm going to pause the recording. Okay, if you were unable to read some of that, here's this board. Should be clear. And here's this one. Again, I don't know when the camera malfunctioned, but all the content should be there. Now there's a pattern. Okay, how did I know that this should be the graph of Y equals X minus 1 quantity squared plus 3? Well, it's not a great mystery, but we're not going to totally clear it up right now. I'll just tell you what the rule is. It's important to understand why the rule is what it is. Otherwise, you forget the rule and you mess up. Okay, anyhow, number 1, that was a graph for number 1. That was Y equals X minus 1 squared plus 3. Now here is definition, what we did to get this orange graph number 1 that we did in a little more detail over here. Okay. The 1 goes here and the 3 goes here. Okay. So if we wanted to do number 3, number 3 is in what column? Where's number 3? 1, 2, there's number 3 still. Okay. Number 3. Instead of 1 and 3, we had 3 and 5. So number 3 is, think about it. What's it going to be? Put it down. If you're wrong, I'll correct it. But have an opinion before you see the answer. Okay, so we have Y equals quantity X minus 3 squared plus 5. Okay. Now, what do you think about number 2? Well, number 2 is in blue here, so here's number 2. And how do we think number 2 is going to be? Okay, well, the negative sign might be a little confusing because you have a negative sign here. And we're just going to write the X minus negative 2 squared. And then if we write it out literally, according to the pattern we've got here, it's a plus. It's going to be plus a -2. Now we can simplify that because x minus -2 is x plus 2. And plus or minus 2 is just a -2. So there we have that. And finally, number 4. So what do you think you're going to have for number 4? Y equals what? Okay. Don't watch me do it until you try it yourself. It's x minus 0 squared plus -3, which is just x squared minus 3. And that makes good sense. Here's our x squared graph. If all our y values become 3 less than x squared, they're going to move down 3 units and give us this red graph. Last thing. Going to do number 5. And use H for the horizontal shift and K for the vertical shift. Y equals part of the x minus h squared plus k. Whatever h is, replaces h here, and you see that we've done that with each of these functions. So if we have number 2, have the -2 here for the horizontal, that's h, it's x minus -2, which of course is x plus 2, and that's what's squared, and then plus the k, which is plus a -2. Okay, we just plug the h and the k in this form, and we get this. Now, this is important because we're talking about how we can build new functions from simple functions. And these functions are no longer as simple as just the plain x squared function, but they're important functions. They can be important functions. The functions that you get here are a whole class. Well, that's a whole class of very important functions for applications from business to science to economics to biology to everything.